In problems 13 through 28, we are classifying numbers on the real number diagram. Every number that we look at will be a real number, so in every problem, we will click real numbers. But instead of starting at the top, let's start at the bottom. In number 13, we are classifying the number 5. Let's see if it is a counting number, which has another name, the natural numbers. The counting numbers are the numbers we use to count objects like apples. 1, 2, 3, 4, 5 apples. So yes, 5 is a counting number. So we click counting, whole, integers, rationals, and real numbers. A number cannot be rational and irrational at the same time. So this is the answer to number 13. Let's look at number 14, where we are classifying 1.6. We cannot have 1.6 apples, so we will not click counting numbers. Let's look at whole numbers. The only difference between the counting numbers and the whole numbers is that 0 is a member of the whole numbers and 0 is not a member of the counting numbers. That's it. So 1.6 is not a whole number. Let's look at integers. The integers is the set of whole numbers and the negative whole numbers. We are not going to call 1.6 a whole number, so we are not going to call 1.6 an integer. We are getting awfully close to the top. Let's look at rational numbers. We are given two definitions of rational numbers. Let's look at the decimal definition. The rational numbers is the set of all real numbers such that its decimal form either repeats or ends. That's what 1.6 is. It's 1.6 and it ends. So therefore, 1.6 is rational and it is a real number. Keep in mind, a number cannot be rational and irrational at the same time. Let's now look at number 15, the number pi. Pi is not 3.14. There are many more decimal places than that. Pi is 3.141592654. It does not end there. The calculator will only hold so many decimal places. We know that pi is not a counting number or a whole number or an integer. When we consider it to be rational, we can see that it is not rational because the decimal value of pi does not repeat and it does not end. So pi is not rational. Let's look at the definition of irrational. Again, we have two definitions of irrational numbers. Let's look at the decimal definition. Irrational numbers is the set of all real numbers such that its decimal form does not end and it does not repeat. That describes pi. The decimal value does not end and it does not repeat. So for number 15, we will click irrational numbers and we will click real numbers.